Today let's look at fractional exponents. So fractional exponent is going to also be referred to as a rational exponent because rational numbers, remember, can be written as a fraction. Okay, so here is our first rule. If you have anything to the 1 over n power, you can rewrite that as a root, so the nth root of x. For example, we have x to the 1/3 power is the same thing as a cube root. Similarly, x to the 1/5 power can be rewritten as a 5th root. Here, the only difference is when that is not a 1 on top, so it's another number. That number will always stick with the x, and the n will remain outside. We call that our index. So a to the 2/3 would be the cube root of a squared. That numerator stays with the letter or the number. Then w to the 5/7, the 7th goes outside, the 5 stays with the w. Here's a couple of quick properties that we can use with our rational exponents. So the product property, we can still split it into its two factors. And then the quotient, we talked about this the other day, but you can split that root into the numerator and into the denominator. So here's an example. We have a coefficient and a variable part, so we can split that 5th root into both pieces, and that will help us simplify. So we can find the 5th root of 243, and then it's helpful to rewrite this as a fractional exponent, so I did that here. The 5th root of 243 is 3, and then if you rewrite it as a fractional exponent, you get x to the 10/5, which we know we can simplify to x squared. Here's another one. We have the 5th root of x to the 5th over 2. So I split that into the 5th root on the numerator and the denominator. Well, the 5th root of x to the 5th cancels nicely, and we get x over the 5th root of 2. However, we also talked about recently that we don't want any radicals in the denominator, so we're going to have to rationalize that denominator. Now, normally we have done this with square roots in the denominator. When you have square roots in the denominator, you have to multiply that square root 2 times in order for it to cancel off. Well, this is now the 5th root. So we're going to have to multiply that 5th root of 2 5 times. Okay, so now you see 5th root, 5th root, 5th root, 5th root, 5th root. Well, the 5th root 5 times is what cancels it off. So on top, we can use that product rule. And since all 4 of these are 5th roots, we can multiply all of our 2s. So 2 times 2 times 2 times 2 is 16. So I get x to the 5th root of 16 on the top. The denominator does simplify to 2, okay, because all 5 5th roots cancel one another off. Here's a brief reminder for your property of exponents. So there's all the properties we've talked about ever. So write those down if you need them. We're going to use these property of exponents to help simplify. So here we start with 64 to the 7/16 times 64 to the 1/16. Since we're multiplying and they have the same base, we can add their exponents. So we get 64 to the 8/16. Use your basic algebra rules. That simplifies to 64 to the 1/2. And then according to our rule from the beginning of this lesson, the half power is the same as a square root. So our answer becomes 8. I would like you guys to please use your properties and simplify this expression. Okay, there's a couple more steps we can do. So here's another one. Same exponent rules. So multiply your exponents. We get 10 times 1/5 is 10/5. That simplifies to the 2nd power. So 12 squared gives us 144. Here there's a couple different things we could do. We could take 27 times 125 and multiply that. That's going to be a really large number. So what I recommend doing is splitting this into 27 to the 1/3 power times 125 to the 1/3 power, because then we can think of those as cube roots. And hopefully you guys know the cube root of 27 is 3 and the cube root of 125 is 5. So you get 15 as your answer. Last thing we're going to do is actually solve equations. So everything we've done so far have been expressions. Here, though, we're going to actually solve for x. So we have x to the 1/3 power equals 6. Well, our goal is to get this 1/3 power gone. So in order to cancel off 1/3, we need to raise it to the reciprocal power. So the reciprocal of 1/3 would be 3/1. And that gives us 3/3, which is just 1. Or you can think about those exponents cross-canceling. But what you do to one side, you have to do to the other. So we have x to the first now on the left side equals 6 to the 3rd power. And then actually go ahead and evaluate 6 to the 3rd power, which gives us 216. And one more example. Here we have x to the 4/5 equals 16. We still need to raise this to the reciprocal power. So reciprocal of 4/5 is 5/4. Those cancel, leaving us with x. However, we need to raise the right side to that 5/4 power as well. So again, go back to the beginning of our lesson. This 4th, or like the 4 goes out on your index, and that 5 stays with your number. So the really nice thing about this, we don't have to take 16 to the 5th power first. We can ignore that 5th power and do the 4th root of 16. Okay, 4th root of 16 comes out to be 2, and then we raise 2 to the 5th power, which is 32.